Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through everything you need to know for the upcoming test. It covers everything we've learned in term 1 thus far. So I'm going to divide this video into 3 sections: Pythagoras, simple interest, and algebra. Let's start with Pythagoras. So Pythagoras is the name of a Greek guy who came up with this theorem centuries ago. His theorem relates to right-angled triangles. So triangles where there is a right angle. So his theorem is that a squared plus b squared equals c squared. So what does a, b, and c actually mean? Well, c is the length of this side here. C is the length of what we call the hypotenuse. So the hypotenuse is always the longest side of the right-angled triangle. It's always the side that faces the right-angled triangle. Now, in the equation, A and B are just the lengths of the two shorter sides. Pythagoras' theorem actually says that the sum of the squares of the two shorter sides is equal to the square of the longest side. In other words, shorter side squared plus shorter side squared equals longest side squared. It's really important that you understand that in this formula, C is always the longest side. It is the hypotenuse. So what this theorem allows us to do, it allows us to calculate the length of an unknown side in a right-angled triangle when we know the other two sides. So rather than using this equation all the time, we might use one of these formula. So here I've got c squared as the subject. Down here I'm going to write the formula with c as the subject. So c equals square root of a squared plus b squared. I can also rearrange this equation and get a equals the square root of c squared minus b squared. These two equations in blue say the same as the equation above in black. So this is the equation you use when you want to find the length of the hypotenuse, when we want to find C, and this is the formula we use when we want to find the length of one of the shortest sides, which I call A. So note the difference. You add when you're finding the hypotenuse, the longest side, and you subtract when you're trying to find the length of the shorter side. And when you're finding the shorter side, C must be first, all right? So hopefully this will make a bit more sense when we see some examples. So let's look at this triangle. It's red, and we are going to calculate the length of x. So firstly, when solving a Pythagoras problem, we need to determine, are we finding a longer side, the hypotenuse, or are we finding a shorter side? So it might look like this side here is longer than that one. I don't know what it looks like to you. But don't be fooled. We've just got to look at which side is facing the right angle. So x is facing the right angle means it is the hypotenuse, it is the longest side. So therefore we're going to need to use this formula here. So it doesn't matter that I called it x instead of c. It's just going to be the square root of shorter side squared plus longer side squared. So make sure you're square rooting the whole thing. Now, I can actually write this answer two ways. I can write it as, so since 4 squared plus 10 squared is 116, I can write it as the square root of 116. That is called exact form. I can also put it in my calculator and get a decimal. So to 2 decimal places, it's approximately 10.77. And that is, of course, a rounded answer. So root 116 is exactly the length, whereas 10.77 is approximately what the length is. So you need to know whether the question is asking you to find the answer as an exact number or in rounded form. So now let's take another example. Please pause and copy this down if you need. So now we're going to look at this triangle and find the length of y. So of course y here, this side is touching the right angle. That means it's one of the shorter sides. So we're going to use the equation y equals square root of c squared, hypotenuse squared, minus shorter side squared. So remember the minus when we're finding a shorter side, whereas we added in the square root when we're finding the longer side in the previous example. So this number may cause you confusion. It's just a number. The square root of 128 is obviously the exact form of this length here, but it's just a number. It's like 11.31 or whatever. So we're not going to do this any differently. So y will be the square root of c squared. Now c, the hypotenuse, is this one here. I know that because it's facing the right angle. So y will be the square root of 18 squared minus root 128 squared. So if you put that in your calculator, you get the square root of 196. This time, the answer is a whole number. So sometimes when you're finding the length in a right-angled triangle, sometimes you'll get a whole number, sometimes you won't. So now we're going to look at a couple of examples that are slightly harder. So again, please pause and copy this down if you need. So as I said before, sometimes it can be a little bit confusing to use the formula a squared plus b squared equals c squared. So I told you to jump to this formula if you're finding the length of the hypotenuse, which is the longest side, the one facing the right angle, and to use this formula if you're finding the shorter side. The only difference is you add when you're finding the longer side, subtract when you're finding the shorter side. When you're finding the shorter side, hypotenuse always has to go first. There is, however, one type of question where you can't jump to these formulas and you have to use this one. And that is where we have the length of more than one unknown side. So let's look at an example of this. So let's do this question. Hypotenuse of an isosceles right-angled triangle is 12 centimeters. What is the length of each of the shorter sides? So if you're given a worded problem like this and not given a diagram, it's always wise to draw one. So in this question, we're told about an isosceles right-angled triangle. That means that two of the sides are equal. Now, because the hypotenuse is always the longer side, the two sides that are equal must be the shorter side. So let's draw a triangle that satisfies this. So we have our right-angled triangle. So this side here is going to be the hypotenuse because it's facing the right angle, and these two sides here will be equal to each other. We're told the length of the hypotenuse is 12 centimeters. So the reason we can't use one of the formula we just used is because now we're finding two unknown sides. So what we're going to do is we're going to substitute what we know into this equation to solve the problem. So let's call the length of each of the shorter sides A. If that's A, this will also be A. They're the same size because the triangle is isosceles. So using Pythagoras, we have shorter side squared plus shorter side squared equals hypotenuse squared, okay? Now, A squared plus A squared is 2A squared, not A to the power of 4. That's A squared times A squared. So I got 2A squared equals 144. Now, when you're solving this equation, you must divide by 2 first, because I need to undo things in the opposite order to BODMAS. So I'm going to divide each side by 2 first, then I'm going to get A squared equals 72. The way I undo squaring is I square root each side. So I've got to square root both sides. I get A is the square root of 72. So that answer is in exact form. Exact form, as I said previously, it means the square root of something. Of course, if I was asked to round it, I would just put that in my calculator, and to 2 decimal places, it's about 8.49. Of course, hypotenuse was centimeters, so this will be centimeters, okay? We're done now. We just had to do it slightly differently because we were finding the lengths of two unknown sides. So let's look at another example where we have to find two sides in the same question. So let's find the value of x in this right-angled triangle. Once again, we'll use Pythagoras, but we're again looking to find two unknown sides. So I need to use the formula a squared plus b squared equals c squared and substitute everything I know. So Pythagoras' theorem says shorter side squared plus shorter side squared is equal to longer side squared. But there's an error in the blue. I want to square this whole thing. I don't just want to square the x, so I need to put brackets here. So 3x all squared, I square the 3 and square the x. And then 20 squared is 400. So now I have an equation to solve. So similar to last time, x squared plus 9x squared collect like terms. And then I have to divide, I have to undo timesing by 10 before I square root. Okay, because you have to undo things in the opposite order to BODMAS when solving equations. So dividing each side by 10, so I divide this side by 10 and this side by 10. 10x squared divided by 10 just gives you x squared. 400 divided by 10 is 40. Now I'm going to square root both sides. And I just get that x is the square root of 40. So once again, that is the answer that I would give if it asked me give the answer in exact form, because that is exactly what the value of x is, or I could give it to a few decimal places. So if it asked me to give to, say, 3 decimal places, it'd be 6.325. I just get that from my calculator. Okay, let's go on to the next slide. Once again, please pause or copy down if you need. So Pythagoras can also be useful in helping us find dimensions in order to calculate the perimeter or area of a triangle. So we're going to calculate the perimeter here. So the perimeter of a triangle hasn't changed. It's just all the sides added together. So we need to find what is this side here. So to do that, we're actually going to have to use Pythagoras twice. First, I'm going to have to find this side so that in this right-angled triangle, I can find the side here and therefore calculate the perimeter. So let's call this side here x. Doesn't matter what I call it. X is a shorter side in this triangle. So just so you know, I'm using this triangle here to find x because I have two known sides, 10 centimeters and 26 centimeters. So x, a shorter side, is going to be the square root of longer side squared minus shorter side squared. And you can use a calculator for that, and you get 24. So now, if I want to find this longer side, I'm going to call it y. Y is the longest side of this triangle. It is the hypotenuse. So y will be the square root of 7 squared plus this time, and I found that x was 24 squared. Okay, so it turns out y will end up being 25. And both of them will be centimeters because the other sides were centimeters. So therefore, the perimeter of this triangle is very simply 25, which is this length here, plus 26. And then the length at the bottom is 10 plus 7, which is 17. So that gives us 68 centimeters in total. So the last thing I want to mention about Pythagoras is it also allows you to tell whether a triangle is right-angled. So if a squared plus b squared equals c squared, so if you're given a triangle with 3 side lengths and a squared plus b squared does equal c squared, that means the triangle is right-angled. If a squared plus b squared does not equal c squared, then it's not right-angled. So, for example, if I give you a triangle like this, and I give you lengths, say, 8, 11, and 14, okay? Is this triangle right-angled? Well, we just check, does a squared plus b squared equal c squared? So, 8 squared, a squared, plus b squared, is 64 plus 121, 185. But c squared, hypotenuse squared is 196. So in this triangle, a squared plus b squared doesn't equal c squared, so no, this triangle is not right-angled. So you check, if a squared plus b squared does equal c squared, then the triangle is right-angled. Otherwise, the triangle is not right-angled. All right, let's go on to the second section of this video, which is simple interest. We now turn our attention to simple interest. So interest is money that you earn in addition to what you invest. So if you invest like $5,000, after a few years you might have $6,000. It's also additional money that you pay back when you borrow it. So if you borrow $5,000, you'll end up having to pay back a bit extra, and this bit extra is called interest. So when we talk about interest, we need to understand the meaning of this word principal. So it's not like the principal of your school. Principal is the initial amount, the amount that you start with. So because the calculation for interest is the same here, whether we invest it or we borrow it, the principal is either how much you originally invest or how much you originally borrow. The idea behind simple interest is you either pay back or earn a certain percentage of the principal each year. So let's look at this question here. How much interest would I earn if I invest $14,000 at 3% per annum for 4 years? Now here, the principal is $14,000. That's how much you started with. So the idea here is that you will earn in interest 3% of $14,000 each year. So 3% of $14,000 is $420. You would earn $420 in interest each year. That means your account balance would go up by $420 each year. So for 4 years, you just times that by 4. So an easier way for us to remember this, rather than working that out, is to use the formula. So the simple interest formula, I equals PRT over 100. So I've said before that P is equal to principal. So R is the rate, and it's as a percent, and T is the time. So T and R have to be in the same units, and I'll explain more about that later. And of course, I is what we're actually calculating, is the interest, the additional money that you earn or borrow. So just so you know, that's the formula I'm using. You might have seen the formula written like this: I equals P times R over 100 times T. It's exactly the same formula. You'll get the same answer whether you use the formula in yellow or the formula in blue. So applying it to this question, I would get the interest equals principal times the rate as a percent, so that's 3, times 4 over 100. And I should get 1680. So what that means is, if this person invested $14,000, after 4 years they'd have an additional $1,680. So let's now have a go at this question. How much interest would I earn if I invest $800 at 6% per annum for 18 months? So we need to figure out what PR and T are. So this is P, because that's how much I start with. Of course, R is 6% and T is 18 months. Now, as I said before, T and R have to be in the same unit. So the problem here is that R is PA, which means per annum or per year. So R's like years, if you like, but T is in months. So when that happens, you need to change T so it's in years. So 18 months, if I want to change that to years, I need to divide by 12. 18 months is 1.5 years, okay? So months to years, you divide by 12. So if you have to change T, usually you will be changing T from months to years, so it's in the same units as R, because the interest rate is usually given as per year. So really important that R and T are the same units. So now that we've changed T so it's in the same units as R, we just use our formula again. So interest equals principal times rate times 1.5, because now rate is in years, time is in years, and then of course we divide by 100, and it's okay if you want to put that in your calculator, you get $72. All right, now let's look at an example where we're paying some money back. So please pause and copy this down if you need. So let's try this question. This time I'm borrowing $5,000 at 7.5% per annum for 4 years, and I'm going to calculate the monthly repayment. So firstly, I need to calculate how much interest I'm going to pay. If I borrow $5,000, I'm going to end up paying back a little more than $5,000 because some of what I pay back will be interest. Now, I said earlier, the calculation for interest is exactly the same whether you're calculating interest that was borrowed or interest that was earned. So I'm still going to use I equals PRT over 100. So I equals P is how much I start with, times rate times time. I don't need to change T here because T is in years and rate is years. So it's I equals P times R times T divided by 100, and you should get $1,500. Now, when calculating the monthly repayment, people usually make a mistake here. They think, okay, cool, I pay back $1,500, so I just divide that by the number of months. I would love it if you could borrow $5,000 and only pay back $1,500. Unfortunately, that's not the case. The total amount, which I'll call A, that this person has to repay, they have to repay the initial $5,000 plus $1,500 in interest. So they're going to end up paying back $6,500. So to find the monthly repayment, so that will just be the total amount they pay back, which is $6,500, divided by the number of months, because it says monthly repayment. So we know that the loan is for 4 years. So how many months would there be? So in the previous example, we went from months to years by dividing by 12. Now we're going to convert years to months by timesing by 12. So there would be 4 times 12, or 48 months in 4 years. And then the answer I get, I'm just going to round to 2 decimal places. That's usually what we do with money. So it'll be about $135.42 per month. All right, now we're going to look at finding P, R, or T. Once again, please pause and copy down if you need this. So let's have a go at this question. How much money must I invest in order to earn $2,000 in interest at 5% per annum for 4 years? So what makes this question different is that you are now told the interest. I was told that there's $2,000 in interest, and I'm asked to find how much money I would initially invest. So in this example, I'm actually calculating P, not I. So there's a couple of ways to do this when you're finding P, R, or T. Now you can use these formula. So P is 100I divided by RT. I get that just by rearranging the simple interest formula. Of course, I could make R the subject and I get 100I over PT. I could make T the subject and I get 100I over PR. So basically, if I'm finding PR or T, it's 100I divided by the other 2 variables. So for this one, I'm finding P, so I could use P equals 100 times, I was told the interest is 2,000, divided by RT. R and T must once again be in the same units, but they are here because I've got years and years. So it'll be 100 times 2,000 divided by 5 times 4. And if I just put that on my calculator, I get $10,000. So that was easy to use. The problem is that you'd have to remember these 3 formula. The other way I could do this question is I could take my formula I equals PRT over 100, substitute everything I do know. So I know that I is 2,000. I know that R is 5. And T is 4. So I can substitute them as well and then solve this equation. So to solve this equation, I just do the numbers separately from the letters. So 5 times 4 divided by 100 is 0.2. So I get 2,000 is equal to 0.2 P. And then if I want to get P by itself, I divide each side by 0.2 and I get the same answer, 10,000 equals P. So if I I'm going to invest at 5% per annum for 4 years. $10,000 is the amount I must invest in order to earn $2,000 in interest. So I would have $12,000, $10,000 plus the $2,000 interest at the end of the 4 years. So you can use either the first method or the second method, whichever one suits you best. Let's look at another example of finding P, R, or T. So let's look at this question here. For how long must I invest $3,000 at 10% per annum for my investment to triple? So this one's a little tricky because we just have to understand what the variables are saying here. So firstly, it says for how long. So I am trying to find T. So like I did in the previous slide, I can use the formula 100I over PR, or I can substitute everything I know into the simple interest formula and rearrange to find T. Either way is fine. So it says, how long must I invest $3,000? So that means I'm originally investing $3,000, principal is $3,000. So it's also clear that R is 10. What would confuse people here is what's the interest? So if you want your investment to triple, a lot of people would say, okay, I needs to be 9,000. But if I was 9,000, at the end of the time, you'd have 9,000 in interest plus 3,000 in principal, you would have 12,000. That means your investment would have quadrupled. In this case, we actually want I to be 2 lots of P. When you want to triple it, you want the interest to be double the principal because you have 2 lots of the principal plus the original principal gives you tripled. So here I would actually be $6,000 because then at the end of the time you'd have 6,000 plus 3,000 equals 9,000. Once you've got that, the question becomes very simple. So we have time equals 100 times interest divided by principal times rate. If you put that in your calculator, you get 20. 20 what? Well, because R was per annum or per year, that means T is 20 years. So if you were offered 10% per annum, it would take 20 years for your investment to triple. It turns out that would actually be the case no matter how much we invested. It'd still take 20 years at 10% per annum to triple if I originally invested $10 or if I originally invested $1 million. It would always take this amount of time to triple because whenever you want to triple, the interest is always twice the principal. All right, just one more example I need to go through for simple interest. So I invest 8% per annum for 5 years and ended up paying back $20,000. How much did I originally borrow? So this one is even trickier than the ones we've done because we don't actually know P or I. We don't know how much of that $20,000 is principal and how much is interest. So what we have instead is A, the amount. So the amount that was paid back, the interest plus the principal is $20,000, right? So what I'm looking for here is P. How much did I originally borrow? The problem is we have 2 variables here. So what we have to do is change this so I have one variable. So I'm going to change I to PRT over 100. So interest plus principal is 20,000, okay? Now what I want you to understand is if you borrowed 8% per annum for 5 years, 8 times 5%, 40%. You have ended up paying back 40% of the principal. So the interest is going to be P times 8 times 5 over 100. And 8 times 5 over 100 is 0.4. You have paid back the principal plus 40% of what you originally borrowed, okay? That happens no matter how much we originally borrowed. If you borrowed 8% for 5 years, you've paid back 40% of what you originally borrowed. So let's solve this equation. So 0.4p plus p, remember p is the same as 1p, So I get 1.4p is equal to $20,000. So this is just an equation like we've seen millions of times. So if I want to undo what's done to p, I undo timesing by 1.4 by dividing by 1.4. So P would be 20,000 divided by 1.4, and you get approximately 14,285. And I'll just round it to 2 decimal places again. Okay, so that means that you would have borrowed $14,285.70, and the other amount, which is like $5,715, that would be interest. All right, let's look at our last topic now of algebra. So the main thing we wanted to get out of algebra was expanding brackets, and we used the distributive law. So the distributive law is how you expand brackets. Remember, expanding brackets, you start with something that looks like this, and you distribute the thing outside the brackets to everything inside the brackets. So it's A times B, and then you also have to times A by C, and then positive times a positive, you get a positive there, okay? That is the distributive law. So let's look at some examples. So there's some really easy examples. 2 outside of x plus 3, you go 2 times x, and then 2 times positive 3 gives you positive 6. Make sure you know how to do it with negatives. 5 something like minus 7 outside of x minus 7. Distribute the minus 7 to the x. Distribute the minus 7 to the minus 7. So the next term would be minus 7 times minus 7, which gives you a positive. So sometimes you will need to expand and collect like terms. So let's say I have something like 4 plus 3 outside of x minus 6. So order of operations means that you do the brackets first. It isn't 7 outside of x plus x minus 6. You have to do this first. So it would be 4, leaving that alone, plus 3 times x, and then 3 times minus 6. Now, this and this are like terms. 4 minus 18 is negative 14, so we get 3x minus 14. So people often find ones like this challenging, where it's just a minus out the front. So I'll make it minus 3x minus 4. So when that happens, what you have to realize is that this is the same as having a minus 1 out the front. Once again, we do the brackets first, so we leave the 12 alone. So it'll be minus 1 times 3x minus 1 times minus 4, which of course gives you a positive, and then we collect like terms. Okay, so if there's just a minus out the front, like there was here, you basically just change the sign of everything in the brackets. All right, now we're going to look at examples where you have to expand 2 brackets at once and then collect like terms. Please pause and copy these down if you need. So let's say we had something like this. So you do the first bracket and the second bracket separately, then you need to collect like terms. So 3 times 2x, 3 times not positive 5, negative 5, minus 4 times x, minus 4 times minus 9, and of course negative times negative is a positive. So this and this are like terms. 6x minus 4x, not 6x plus 4x, because this minus belongs to the 4x. 6x minus 4x is 2x, minus 15 plus 36 gives you positive 21. So sometimes you need to expand brackets where you have a couple of variables. So let's try this one here. So where we have a variable outside of the brackets, we don't do anything differently. We distribute it to the first. Now, x times x is not 2x, it's x squared. And then we distribute the x to the negative 4. So x times negative 4 is minus 4x. Okay, then we do the same here. We minus 3 times x, and here we have minus 3 times y. So now we need to look for like terms. So this term and this term, they are the like terms, negative 4x and negative 7x. X squared is not a like term. X squared has 2x's, this one and this one only have 1x. So minus 4x minus 3x is minus 7x minus 3y. The 3y has no like terms. This is as simple as the expression can get, and we're done. All right, let's look at a more problem-solving type of question. So here we're talking about a rectangle. The length of the rectangle is x and the width is 5 centimeters shorter than the length. So if the length is x, the width of the rectangle is just x minus 5 centimeters shorter than x. So that means the area of the rectangle, would be length times width. Now this is called factorized form because it's something times something. That's what factorize means. Something times something. So in expanded form, if I expand the brackets, x times x times minus 5. So both of these are the area. This one is in expanded form, okay? So if x were, say, equal to 13, then that would mean that the area would just be x squared, 13 squared, minus 5 times x, which is 13. And of course, I just get 104 centimeters squared, okay? So the distributive law can help us with some area problems. Let's look at another type of area problem where the distributive law would help us. So we're going to find the area of this shape in terms of x. So let's start by finding the lengths of the unknown sides. So if it's 4 from here to here, that line plus this line must equal x plus 8. So this line here is x plus 8 minus 4, which is x plus 4. But this one here must be the same. That's what this little line here means. This and this are the same length. So that means this line here at the bottom is x plus 4 plus 3, which gives x plus 7. So now let's find the area of this shape in terms of x. So what we can do is we can divide it into two rectangles. So this one here, area is length times width. Length times width. It's 3 times x plus 4. And then, of course, the area of the bottom shape here is 4 width times length. So the total area of this shape is 3x plus 4 plus 4 outside of x plus 7. You can see how the distributive law is being used here. If you expand the first bracket, 3 times x, 3 times 4. Second bracket, 4 times x, 4 times 7. And now we collect like terms and we get 7x plus 40. That would be the area of this shape. All right, let's look at just one other example where the distributive law is useful. So here I'm going to use an example of a rectangle again and show you that distributive law is very helpful when we're looking at solving equations. This problem requires an equation. So the perimeter of the rectangle is 60 centimeters, length is 6 less than double the width. What are the dimensions of the rectangle? So let's let the width be x. So then if that's the width, the length is double the width minus 6. 6 less than double the width. So the perimeter of the rectangle is 2 times the width plus 2 times the length. And that's equal to 60. Now we have an equation to solve. Remember, brackets come first. So I have 2x plus 2 times 2x, 2 times minus 6. So when solving the equation, collect like terms. And now we have an equation here to solve. So remember, when you're solving equations, you do things in the opposite order to BODMAS. I want to undo everything that's been done to x. So first I'm going to add 12 to both sides. And I get 6x is equal to 72. And the way I undo timesing by 6 is dividing by 6. And that means I get x equals 12, right? But x was the width. So that means for this rectangle, I found that the width is 12. The length is 6 less than double the width. So the length is double the width minus 6, which is 18. So this rectangle would have a length of 18 and a width of 12. And so its perimeter is 18 plus 12 plus 18 plus 12, which equals 60. So the distributive law is very useful in area and perimeter problems and also in solving equations, so make sure you study it. All right, sorry for the long video. Best of luck for the test. Please ask any questions if you need. Good luck studying, but you're a superstar. You will ace it. Have a great day from the luckiest maths teacher in the world.